Once again, welcome back to this video tutorial. We can discuss about the assembler directives. So before that, we need to understand something about the assembly language programming. And assembly language programming is similar to a machine language programming. But here in this assembly language programming, we use certain mnemonics as instructions. Okay, mnemonics means strings that are similar to our English language words. So these mnemonics are used as instruction and they are directly written in the program code. Hence this assembly language programming become more reliable. Also it become more easier for the programmer. Okay. Next is about the assembler. What is the assembler? It's a system software actually, just like our compiler, and is used for converting a machine language equivalent of a program which is written in our assembly language program. So this assembler is used for converting an assembly language program to its equivalent machine language code. Further, they are converted into executable code. Okay, so for performing assembler functionalities, assembler requires certain information from the programmer. Okay, for getting the functionality from the assembler inside our program, we need to specify, or the assembler requires certain information from the programmer. So such informations are passed through the program by the programmer with the help of certain mnemonics or certain alphabetical strings. Such alphabetical strings are actually named as assembler directives. So inside our program, there exist certain alphabetical strings with predefined meaning. They are actually used for passing certain information to the assembler in order to get the functionality. Okay, so such strings are known as assembler directives. We have different assembler directives. We can discuss about certain assembler directives in this video. The first one is about the assume. An assume mnemonic or the string assume is actually used for assuming certain user defined name to our logical segments. Okay, assume is an assembler directive which is used for assuming certain user defined name to our logical segments. Just like this is the syntax of assigning name to logical segments. Assume space cs colon code. This code is a user defined name which is assigned to the code segment. Okay, assume ds colon data. This actually tells the assembler that for any instruction which refers to the data in the data segment, data will found in the logical segment data. So inside for our program, the data we are going to store inside a particular data segment. That particular data segment is labeled with a user defined name data. So similarly, we are going to write an assembly language program in which we have a set of instructions. So these instructions of our current program we need to store somewhere in the code segment. So that particular code segment is labeled with a user defined name, that is this code. So the code in which our program code is present is assumed with a username code. User defined name code. Similarly, the data segment in which the data needed by our program is present is labeled with the user defined name data. Okay. Next is about DB. DB means is a directive used to declare a byte type variable or to store a byte in memory location. Okay, so consider some example. Price db 49h 98h 29h. What is the meaning? Here it declare a 3 byte and 3 bytes are together named it as what? Price. Okay, here define byte. How many bytes need to assign or allot? Here we have 3 values to store, each value in a single byte. Okay, so this particular data need a byte for storage, this data need another byte, and this data need another byte. As a total, here it declare three different, or here it allowed three different bytes, and in each byte allowed the values 49, 98 and 29 respectively. Okay, and these three bytes together named it as price. Okay, here declaration or allotment and initialization taking place using this single statement. Here, name space db space inside the single quote ABCDEF. That means define bytes. How many bytes? One, we need to store 6 different characters as a total. Here it allowed 6 bytes, and in each bytes we need to store these characters respectively. The first byte store ASCII of A, B, C, D, E, F, etc. And these 6 bytes together named it as a user defined name. Okay, so the third example, temp db 100 dup inside a parenthesis specify what? A question mark. What is the meaning? Here we need to allot 100 bytes, and these 100 bytes are assigned with a name, user defined name temp. But this DUP question mark indicates that here we need to declare or just allot 100 bytes in our memory, and no need to initialize this 100 byte with any value. Okay, this question mark indicates that we need to just allot 100 bytes and kept it as uninitialized. Okay, so suppose the statement is like this: temp db 100 dup inside the parenthesis 0. Then the meaning is different. That what's the meaning? Allot 100 bytes, and this 100 bytes together named it as temp, and in each byte initialized with the value which is present inside the parenthesis. Here it is 0. But here in this particular example, here it is marked as question mark inside the parenthesis. That indicate we need to allot 100 bytes, consecutive 100 bytes, and kept it as uninitialized. Instead of this question mark, suppose here we have a value 0, then we need to initialize each of the byte of the 100 total bytes. Each of the byte is initialized with the value 0. Okay. Next is about DW. DW means define word. This directive is used to define a variable of type word or to reserve storage location of type word in memory. Okay, that means if we want to allot 2 bytes for storing a particular data, or we need a 16-bit representation for a particular given data, in that case we can use this assembler directive, define word. Okay, if we need only 1 byte for storing a data, then we can use db. Okay, example, multiplier space dw437ah. This will allot 2 consecutive bytes in memory and is labeled as multiplier, and in that 16-bit we store this value. Using that 16-bit of information or 2 consecutive bytes, we can store this value. Next, exp1 dw1234h, 3456h, 5678h. What's the meaning? We need 1 word for storing these 3 values, and these 3 for the allotted memory location. Each value require 1 full byte, 1 full word for its storage. So for this particular value we need 1 word or 2 bytes, and for this we need 1 word or 2 bytes, and for this also we need 1 word or 2 bytes. As a total 3 words or 6 bytes are required, and these memory allocation together named it as exp1. Okay, next is about stor1. Just a user defined name. Again dw 100 dup in parenthesis it is 0. What's the meaning? Allot 100 words in our memory, and these 100 words are kept as initialized with the value 0 which is present inside this parenthesis. 100 word means total 200 consecutive bytes are allotted, and as a whole it is named as STOR1. Okay, this is a user defined name which is assigned to the 100 words, and each of these words are initialized with the value 0 which is present inside this parenthesis. Clear? Okay, next is about end assembler directive. This end directive is placed after the last statement of a program to tell the assembler that this is the end of a program module. Simply an end actually indicate the end of a program. So this end must present at the end or last statement of a program. Okay, end must come as the last statement of a program module, indicate the end of a program. Okay, next about end P or end procedure. Instead of end, here we have a P also. Okay, end P. This end P indicate end of a procedure. So inside a program we have any number of procedures. We can declare and define any number of procedure. So this end P is associated with the procedure body. So at the end of the procedure body we can use this. Procedure start actually indicates the start of a procedure, and at the end of the procedure the start NP indicate the end of the procedure start. Next is about end S. Okay, this end S directive is used with the name of the segment to indicate the end of a logical segment. Okay, so this one indicate this is the start of a code segment in which inside this we can type any number of instructions that comes inside our program. So at the end we need to specify the end of this code segment. This can be represented using name of the code segment space ends. This ends indicate end of a logical segment. Okay, so consider this. Assume CS colon code comma DS colon data. This one indicate our code of our program present in a particular code segment which is labeled as code, and our data needed inside our program is stored in a particular data segment which is labeled as data. Okay, so this one indicate the start of our program code and is present inside the code segment which is labeled as code. So code segment indicate the start of the code. Inside we can specify the instruction comes in our program. At the end we can specify the end of our segment, that is code ends. Next is about EQU or equate. This EQU directive is used to give a name to some value or to a symbol. We can assign name or some value to a symbol using this EQU assembler directive. Just like this, label EQU 0500H. So inside a particular memory location which is labeled as label, that location is equated with this value. So this label now indicate a constant 0500. Again here a name, user defined name addition, which is equated to a instruction add or a mnemonic add. So this user defined name addition is equated to a user defined name equated to a instruction or mnemonic. Okay, so that after these particular instruction, instead of using this add instruction, we can use the term addition instead of add. Or after executing this one statement, equate statement inside the program, we can use the name addition instead of this add instruction. Okay, this is the usage of this EQ. We can assign label to a constant value or to some label or variable or symbol or some instruction or to some mnemonics. We can add or equate some additional name to a variable or symbol. Okay, next is another assembler directive, that is even. This instructs the assembler to increment the location of the counter to the next even address if it is not already in an even address. Okay, so this even is an assembler directive which instruct the assembler to change the current location of the instruction pointer or location pointer to point to the next nearest even address location. If it is now not in an even address location, then the location pointer incremented to point to the next even address location. If the word start at an odd address, the 8086 will take two separate bus cycles to get the data. That means if the word start at an odd address location, the even bank and odd bank concept will not work properly. So we need to make or we need to store a value that is starting from an even address value or even address location. Then only we can make use the concept of even banking and odd banking of our memory system. Then we can reduce the number of bus cycles need to read a 16 bit of information. That is, then in that case, if we have to access even bank and odd bank together, then it require only one bus cycle to access the complete 16-bit set of information. Okay, so this is the usage of this even assembler directive. Increment the location counter to point to the next available even and next nearest even address location. If it is now currently not present in an even address location, this assembler directive even increment and point to the next nearest even address location of our memory. Okay, this even, then procedure root, then inside the procedure body we can specify any number of instruction at the end. Here it is the root procedure ending. Okay, this even here indicate that we need to move the location counter to the nearest even address location. From there we can store the instruction present inside this procedure root. Okay, next is about group directive. This group directive is used to group the logical segments named after the directive into one logical group segment. Okay, this group directive is actually used for grouping the name of various logical segment into a single group. For example, program, this is a user defined name, program space assembler directive group space code comma data comma stack. If all these groups, all these logical segment names like code, data and stack, all these are grouped together to form a single group, and that group is named as a user defined word program. So that after grouping, the assume can be used the label program. Just like this, assume CS colon program, DS colon program, SS colon program. That means this assume directive make use the name of the group. So while using this, from this group the CS is assigned with automatically the address of code segment, and data segment register is automatically assigned with the data segment address which is available in this group program. And similarly this stack segment register is loaded with the which one? The stack segment address is loaded with the stack segment address which is available in this program. So after grouping all these logical segments named together and named it as a group name program. So for assuming, we can use this simple name program instead of using these names separately for each of the logical segments. Next is about extern and public directive. Extern informs the assembler that the names, procedures and labels declared after this directive have already been defined in some other assembly language program. Not assembly language program, some assembly language program module or assembly language defined in some other module. Okay, that means so inside our program we may have different program modules. Okay, in one module we can define certain procedures, variables, etc. If we want to access that from another module present inside the same program, we can make it as external and we can make use the directive external and public. Okay, in a program we have more than one program modules or segments in which one module contains certain variables or procedures. That variable and procedure can be make use in another module of the same program with the help of these external and public directives. So consider this example. This is the first module. Okay, this is the module 1 indicate a particular segment of our program. Here we have a factorial variable or some procedure name with specifier public. This is public actually, and also specify the type as var. Okay, that indicate this var type actually indicate that we can access this factorial from everywhere in the 1 MB memory of 8086 system. That is why this var. If it is near, then this factorial can't be accessed from the outside of our current segment. Okay, if the type of this factorial is set as var, that indicate the factorial can be accessed from everywhere in the entire 1 MB. So this one indicate the end of the module and this factorial is declared as public and var. So from the next module, module 2 segment, here we can declare the factorial. Here we want to access this factorial and represented like external factorial var. What is the meaning? This external keyword preceded this factorial actually indicates that this factorial is already defined somewhere in the program in some other module. Okay, and that factorial, while actually define this factorial here, we need to specify its type as public. Then only we can access that variable or the procedure in some other module of the same program. So while accessing a variable or procedure of one module to some another module, we need to specify the directive extern before the procedure name or variable name. This extern actually indicates that the extern factorial. So that factorial is defined somewhere in some other modules of the same program. Okay, here this public factorial actually indicates that this factorial is actually set as public. Its specifier is public so that it can be accessed by any module in the same program. Okay, so for accessing from the some other modules, make it as public, and while accessing from other module, set its type as external. This will indicate that here we are going to access factorial, but it is already defined somewhere in other segment. Okay, so these public and external are always related. Next is about label directive used to assign a name to the current content of the location counter. Wherever the location counter is now pointing, we can assign some name to that location with the help of label. Okay, data, segment, array, db, 50h, gup, which is uninitialized, lock, label, byte, var, and data ends. So after these, inside this data segment, after declaring 50 bytes and named it as array, in the next now the location pointer is pointing to the 51st 51th location. Okay, after allotting 50 bytes, the 51st byte of our data segment which is pointed by our location counter. Now that location counter is labeled as a user defined name LOC using the assembler directive label. Okay, and this byte and var, these are the data type of that particular location which is pointed by this LOC now. Okay, so this label is a directive used to assign name to a memory location. So after allotting 50 bytes, the 51st byte of the data segment is labeled with LOC because the 51st byte is now pointed by the location counter. So that location is labeled with the user defined name LOC, and this byte and far actually indicate the type of that label. Okay, byte indicate this name is only assigned to the 51st byte. Okay, the name is only for a single byte, which is the 51st byte. And this far data type indicate that the value present in that particular location, which is now pointed by this name LOC, that can be accessed from everywhere of the 1 MB memory. Okay, that is why the type far. If it is near, we can't access that LOC label, which is pointed to some location of our memory. That location can't be accessed from outside of the current data segment. Okay, so this is the meaning. Next is about length. Length indicate length of the segment in byte. Not the segment used to get the length of an array or a string in byte. Okay, move cx comma length array. This instruction indicate cx register is loaded with the length of the array in bytes. Array is a byte and its size is assigned to the cx register and is assigned in bytes. Number of bytes actually it represents. That is loaded into cx register. Local is another directive. The variables, constant, procedures declared as a local in module are to be used only by that module. The local variables of a program module. That means the local variables, procedures, constant. These constant variables, etc. that are going to use inside a procedure only. Such variables and constants are declared as local. Indicate that they have only local scope. They exist inside the current module only. It cannot be accessed from the module. It cannot be accessed by some other instruction which are present outside that module. That is the meaning of local. For local declaration, that means the variables constant etc are declared as local, then they cannot be accessed from outside of the current program module. Okay. Name, which is used to assign a name to an assembly language module. Name is a directive which is used for assigning name to a assembly language program module. Next is about the offset. It computes the 16-bit displacement of a particular label. Inside a particular segment like data segment or code segment, this offset is used for getting the displacement inside a logical segment in 16-bit length. Okay, code segment move si comma offset of list, offset list code ends. What's the meaning? This si is assigned with the offset value of a memory label list. Okay, data segment list db10h data ends. Okay, so the list actually present here. Okay, inside this data segment, here we have a particular memory location. This is actually 1 byte, and that 1 byte is assigned with the value 10 and is named as list. So inside the data segment, its displacement or offset value we need to load into source index register using the assembler directive offset. Okay, in order to get the offset value of a memory label, and the value is represented in 16-bit information and is loaded into SI register here. Next is ORG or origin. This directs the assembler to start the memory allotment for a particular segment or block from the declared address in the ORG statement. Usually, while starting the code storage inside the code segment, the program codes are going to store from the starting location of the code segment itself, that is from 000th displacement position of each of the code segment. Okay, if an instruction like this, if org200h statement is present in a starting of a code segment module, if present a statement like this org200h in the start of a code segment module, then inside the code segment skip 200 position or 200 bytes and locate to a particular point, or locate to or pointing to 200h. From that point onwards we can store the code program code present inside the code segment. If this statement is not present, a statement like this org200h is not present in our program, then our program code or whatever instruction present inside the code segment that are going to load in our code segment from an displacement value 0 itself. From the beginning of the code segment itself, we can store the codes of our program one after the another. If an instruction like this org200h present in our code, then after setting the start of a code segment, skip some 200 location or skip some starting bytes and pointing the location counter to a memory location inside that code segment at 200, from where we can start loading our program code. Okay, next is about PROC or indicate the procedure. This marks the start of a named procedure. Okay, result PROC near. This indicates that result is a procedure which is to be declared by a program located in the same memory segment. That is why this near. Okay, result is a procedure which is to be used by another main program. That main program is also present in the same memory segment. That is why this near. If it is far, then indicate that this result procedure is used by some main program which is not present currently in the same segment, which is present in some other segment. Okay, result PROC far. This far is used for the procedure to be called by the programs located in different segment of the memory. Okay, so this one indicate, this far or near indicate the type of our declared procedure result. This PTR or pointer actually act as a pointer to a register content or to a memory location, like move AL comma byte PTR of SI. What is the meaning? This indicate the pointer is pointing to SI. So the content of SI pointed by this PTR is loaded into AL as a byte. That means the SI is pointing to somewhere in memory. That particular byte is loaded into AL register. This byte indicate the type of the pointer. It requires only one byte of information which is pointed by this SI. Okay, if INC word PTR content of 300h, what is the meaning? This indicate here it is the type is word. That means we need to increment a word or two consecutive bytes of information which is pointed by this PTR, and the PTR is pointing to a memory location 3000. So from starting 3000, increment the content of a word. So the value present at C3000 and 3001 taken as a single value and perform an increment operation. So this PTR is actually used for pointing to a particular memory location. Okay, SCG, and is used to decide the segment address of the label, variable or procedure. SCG segment keyword or assembler direct segment is actually used for declaring logical segments of program or different segments of the program, and this SCG is used for, this is an assembler directive, this is used for getting the data segment or code segment or stack segment address of various program modules or procedure variables, etc. For example, move AX comma SCG array. This array is actually indicate the starting address of a list of numbers or strings, etc. So here this SCG assembler directive take this segment address of a particular data segment in which this array label is present. So that particular segment address is loaded into AX register using this SCG. Okay, and sorry, here again a mistake. Here it is AX. Okay. So after loading that segment address of this array label to AX register, from where we can move that to the data segment register. Okay, we can directly transfer a segment address to the DS register. So we need to place the address to the AX register first. From AX we need to load into data segment register. Okay, and next is about the segment. This is SCG. Okay, this is used to get the segment address of a variable or a procedure or some label. Okay, just for taking the segment address. Segment address means the segment in which the variable present or the procedure present or the label present. Using SCG, we can take the segment address. This segment, full segment, this is another directive. This indicates the starting of a logical segment. Okay, this indicates name of the user defined name to the segment, this segment and global. And this indicates the end of that program segment. This indicates exe.code is a program or logical segment, indicate the start of the segment, and its type is global. If it is global, what's the meaning? Label, variables, constant or procedure declared as global may be used by any other module in the program. Okay, the global variables, procedures, constants, labels and modules. Here it is a module or a segment, which is, here it is a segment actually. Okay, the segment is set as global. That means the segment, program segment can be accessed from anywhere in the program. Okay. So this segment is actually, segment assembler directive is actually used for indicating the start of a logical segment. Here it indicates the start of a segment. Its name is exe.code and this type is set as global. That means this segment can be accessed from everywhere in the program. Okay, next is about short. That indicate only one byte is required to code the displacement for a jump. If a jump instruction is associated with assembler directive short jump label and is used modified as jump short label. This one indicates that this particular jump indicate a jump inside a 256 bytes. A jump inside the same segment, and inside we can jump from the current location 127 bytes forward a maximum or 128 bytes backward as a maximum. This type of jumping is represented using the assembler directive short. Jump short label means we can jump from the current location to maximum 127 bytes forward or maximum 128 bytes backward. It's a total 256 bytes. Okay, this indicates a short jump. So, in order to represent such a short jump, we can use the directive short. Next is about type. This directs the assembler to decide the data type of the specified label and replaces. We can replace, if we want, then we can replace the type of the label by decided data type. Okay, type actually indicate the type of a variable, okay, variable or data, and using the same type we can change the data type. For example, one word, a word type data, the type of a word type value is represented as 2. The data type of a word type value is marked as 2. The data type of a double value is marked as 4. And type of a single byte value is marked as 1. Just like integer in our C program. Integer indicate that integer type value require 2 2 bytes in our memory, a floating point value require 4 bytes in our memory, a single character require 1 byte in our memory. Just like that, here a byte type value require a data type 1, a double word require 4 bytes, a single word require 2 bytes. Okay, or represent 2 as a type. Okay, suppose string is a word array. Here we have a label string which indicate a word array. Then move ax comma type string. That means we need to get the type of this label string and is loaded into ax. Here we assumed that string is a word array. In case of word, the data type is 2. So after executing this, ax is loaded with the value 2. Suppose assume this string is a byte array, then after executing this move ax comma type string, this ax is loaded with the value, the type value 1. Okay, suppose the string is a double word array, then the type loaded into ax register is 4. Okay, all these are important assembler directives available for assembly language programming. So prepare well. Okay, thank you.